Alright, so it's going to be a good amount of math today, but please take good notes so that you have them. Hey, good thing is, none of these variables are new. Right? Now, what did we say from yesterday is true about free fall?
In order to free fall, you have to have zero error.
Zero error. Okay? So we are assuming here that we do not have any error, and what that means then is that all objects are going to accelerate towards the Earth at a constant acceleration of 9.81 meters per second squared. So, if I had a vacuum chamber and I dropped a ball in that vacuum chamber, I could predict exactly how fast it would be going after 4 seconds, after 12 seconds, after 450,000 seconds. It'd be going pretty darn fast after that long. And that's what this equation allows us to do. Also, if I found the maximum velocity that something in a free fall was, I could predict exactly how much time it required to get to that speed or velocity. Okay? Any questions about these variables? We're familiar with velocity, right? We're familiar with it, that its most common unit is a meter per second. We're familiar with little g, which is the acceleration due to gravity, which is always 9.81 meters per second squared. That means if I drop this golf ball, or if I drop ether in a vacuum, they accelerate the same amount. Okay? Ether with an oxygen mask on it. You wouldn't want to drop it in a vacuum, no oxygen. Okay? And we know what time is. Time it takes for the object to fall. So let's do our problem. What's the very first step for all problems?
Find the variables.
Find the variables. I am so glad, Mari, that every time I ask that, you say find the variables. That's what I want. Good job. Yeah, sure.
2 millipoints.
4 nanopoints. Yeah. And I'm not very liberal in giving out extra credit. You only need 999,999,996 more nanopoints to get 1 point of extra credit.
I'm going to have it by the time I'm done.
Okay? So it says, how fast is an object traveling? What is that asking you to solve for?
Velocity.
Velocity. So there's my first variable. Then it says after 3.75 seconds, what is that? Whoops, not a 9. And we're missing something.
Gravity.
Oh, you guys know what gravity is?
9.81.
Oh, the acceleration to gravity is always the same number. Oh, that's nice. Yes?
Do we have to just put the 1?
1. What 1?
Gravity, can't we just do 9.8?
No, I want you to do 9.81. Okay? Alright, you guys solve. Just don't say it out loud. I want to make sure everybody else can solve. Everyone, I want to see the answer in your calculator. Actually, that's not really that hard. I'll probably make it a harder problem.
No.
Yes. No. Calculate how fast your top falls.
This is a super easy equation, guys. Even if I was solving for t, it still wouldn't be overly difficult.
We're talking to our friend Shane about
Yep. Yep. I want to see. I want to see the unit.
schooling.
Unit is not right.
Wait, what was your unit?
Your unit isn't right. Your unit is not right. Your unit is not right. Your unit is right.
Mine off the accident.
Your unit is right.
What did you put?
No, that's acceleration.
Do not square based on the units. Does that make sense? Kathy? Only square if the equation tells you to square. Like if there was like a t squared. Yes. 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 Where's your unit? Yes. Unit is wrong. Yes. 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 Alright, so about half of you got the units wrong. So if we plug in 9.81 meters per second squared times 3.75 seconds, I've got a meter per second squared multiplied by a second. What's going to happen?
One of them seconds don't go away.
Okay, this is on top, this is on bottom because of the slash. So you are canceling out one of the seconds, leaving you with a meter per second, which is like 36 something, right? Now, remember how I said if all your other units are in their most common units, your answer will also come out to be in its most common units. So all you need to look at is this the typical unit for time? Is this the typical unit for acceleration? And the answer is yes and yes. So what is your typical unit for velocity? Meters per second. Okay? All right, so here, you don't have to put this in. This is just showing you, if you're in free fall, you have no air resistance, right?
Right.
So there's nothing that's going to inhibit your acceleration, correct? Okay, so it means it's consistently accelerating at 9.81 meters per second squared every second. So after 1 second, how fast do you think you're going to be going? All right, and then add another 9.81 for every second. You can imagine how fast you would get over even 60 seconds. It'd be going pretty fast, wouldn't it? Imagine 1,000 seconds. It's pretty darn fast.
Keep this up there.
Just add 9.81 to every one. Go ahead and get this in.
Yeah, I only have like 5 pages left. Backs of pages.
Yeah, I hate.
Can't do
Wasting people. Can't do that good with hands. And she writes it.
Okay, it says note that the Earth's gravity is always 9.81 meters per second squared, but then it says near the Earth. Why does it say near the Earth?
Because gravity gets weaker and weaker the further you go.
Ah, everybody hear what Mari said?
Yep.
Say it louder, Mari.
The Earth's gravity, force of whatever, the gravity gets weaker the further you go away.
Okay, you guys remember doing Newton's gravitational equation where we said that there are two variables that determine gravity. What was one variable? Distance. What was the other variable? Mass. Okay, so do you remember it being far away or being close? Which one was going to give you a greater gravitational force?
Close.
Close. Okay, so if you have a stronger gravitational force, it's going to change your acceleration, won't it?
Yeah.
Okay, so we're assuming near the Earth. Now, when we're doing these math problems, you can always assume 9.81 unless I specifically tell you it's different. Okay, so we're going to make the assumption that we're near the Earth, near the center of the Earth, or close to the Earth, that the gravity is going to be 9.81. So I want you to write this in, and I want you to try to, on your own, solve it. And after, we'll go over it. Don't let anybody else see that. You're done, raise your hand. What's up, right? What did you do in your calculator? So you took this and brought it over here? Why'd you do that? Don't you want to get t by itself? Subtract? No. You're bringing this over here. Anybody else done? Yep. Take your time, write down your variables on the side. You're probably a good safe guess that we're using the same equation we just got done using. There. Yep. 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 Anybody else done yet? Unit's wrong. Yep. You don't have to write that much of it out. And your unit isn't right. Nope. What variable are you solving for? Not done yet? What's the unit? Oh, I was looking at that. Look at that. Still working? What I haven't seen yet. That'll do. Where you coming? all right. Where's your equation?
Oh.
You could write the equation out and then plug in to your equation.
Did you use your calculator to do
All right.
that? Lie to me.
Got an answer? You got it set up right? Solve for it. T, you do. Okay. So are you taking this divided by this or this divided by this? If you take this divided by this, you'll be moving this.
Yeah.
over here. Everything away. This down here. This divided by
That yogurt is
that makes sense.
Every yogurt is
You get.
I like how we
Okay, it's like a G.
have.
Okay, so quickly, we've got a V. That is 34.5 meters per second. And we know G, because we're close to the Earth, we're making that assumption. And we have our time. We know we're using this equation then. Then plug in and solve. I need to use a better marker than that. So do you guys understand that I'm taking V and what it equals and I'm replacing it in the equation? I know G, I'm taking what it equals and I'm replacing it. Now, again, I've stated this quite a bit. You're solving for T, which means everything, T needs to be alone. Which means I gotta get rid of this. Okay? How do I get rid of this if I'm currently multiplying? I will cancel and do it over here. There was a few people, wasn't a ton of you, that flipped it. Okay? If you are taking and getting rid of it over here, you're dividing it down here. Okay? I think you should have gotten what, 4.5 or something like that? 3.5. Close, close. All right. All right. All right, we got our hang time equation. No. Hang time.
Half of it.
Wow.
Yeah, I jump up in the air and so actually, believe it or not, when I tried out for the professional ultimate frisbee team a couple years ago.
A couple of years ago?
Yeah. Ultimate frisbee team.
Did you not make it?
I made it the first year.
You got kicked out.
No, the second year I wasn't in very good shape.
You didn't make it? Really? Oh,
You guys win the first year?
We were middle of the tier.
Is it like a bunch of players?
It's like football with the first.
Except for special contact.
Wait, did you say you did do good?
We were middle. Yeah.
You're just adding distance. But there's no velocity. Yeah, you're getting rid of velocity, putting in distance.
Okay, sure. So the reason, what I was trying to say before you guys asked me a whole bunch of barrage of questions was at this tryout, they had this device that you stood on and you just jumped off of it and jumped straight up and landed on it, and it could tell you your vertical. And it's because of this. What it's doing is it's measuring the time that you're in the air. And if it knows that gravity accelerates you at a constant rate, you can determine how much of a vertical you have. That's why it's called the hang time equation. Okay? Or you could say this. How high did the object drop from? If you know the time it took for the object to fall and hit the ground, you can figure out how high it was that it was dropped from. Okay? So it's a pretty cool contraption that they use. But it measured your release point based on contact, and then it measured when you hit, and then the time difference between that, it then gave you your vertical. a little bit better, quicker than using the old school jump and touch the. You guys probably aren't familiar with that.
Yeah.
So,
Volleyball.
really?
Volleyball did.
Yeah.
Okay, how high?
What was my vertical? 29 inches. It's not very good anymore. It had a 36-inch vertical in high school.
Dunk. Graham couldn't dunk.
That's a yard.
Oh, I didn't think
No, wait, that is a
His
yard.
hip will be up.
You jump a yard in the air.
Yeah, I have, my vertical has significantly decreased as I've gotten older.
This time.
Yeah, I'm not as old as your guys' parents, but you will know when you get to be my age what everyone when they're old is talking about when they say you deteriorate over time.
Do you need to square the sentence?
You're talking about when you square the time?
Yeah.
Yep.
So, just square that.
Okay, so write this in. Okay, write this in and write the variables at least. You should be able to do that. It's hard to see. Just wait. We'll go through this one together. Abby, could you give me a variable? What?
Little g,
Little g? What is it?
9.81.
Shane, could you give me another variable?
Time.
Now, based on this information I just wrote down, would you be able to tell the difference between last equation and this equation? Just from these two variables? No. Because don't this new equation and the previous equation both have g and t in it?
Yes.
So we have to continue to read the context of the problem. It says, how far does the object fall? Is that talking about velocity or is that talking about a distance? So we are going to use our d equals 1/2 g. What is half of g?
4.4.
So you can actually write this equation if you want instead of the previous equation. It simplifies it for you. Everybody hear what I just said?
Yes.
This equation and this equation are the exact same. This is just a simplified version of this. Half of g is 4.905. Does that make sense? So if you prefer to use this equation instead of this equation, which just means you're doing less stuff, I would use this one if I was you. So everybody understand how it's the same equation?
Yeah.
Okay. You're looking at me like I'm throwing rocket science at you.
No.
Trying to get out of here as fast as you can.
Very.
Okay, so now I really don't even need this then, do I, anymore?
I'm very.
No, I don't. Okay? So, D equals, anytime I plug in a variable, I don't know if you've noticed this by now, I always put it in parentheses just so that I can isolate what it is that I'm doing. 8.9 seconds, but then I do what with the time? And I only square it because the equation says to square it. I'm not doing it based on the units. And technically I should have the units in here, which would be a meter per second squared. Alright, when you do that, what did you get? 800? Is that true?
388.
388.
Is that what you said?
388.
Not meters.
388.8 9.5. Now, you're squaring your seconds, and that should cancel out with your squared seconds there, giving you a. Now, does that make sense?
Yes.
Why does that make sense? Because it's the most common unit for distance. Now, I think this is the last. So this is just showing you another slide how much distance it will travel in a second. But I want to do this one. And I'm going to do this one with you. So, I want you guys to write this equation, or not the equation, write the problem down, please. Okay, so a ball is dropped off a two-story building 98 meters high. What variable is that? That says how long will it take the ball to reach the ground. And since we've already kind of put in G and made a new equation out of it, we don't have to worry about G for this guy. The reason I want to show you this one is because when you plug in D for D, are you guys paying attention and following me here? You're solving for time. Okay? The first part shouldn't be too difficult. I've got to get the t to be by itself, correct? So what would everyone say that they should do? Okay? Divide by 9.905 here. That cancels that out, and do it over here. Now notice, do I have, is t by itself? Yes, but is it t? What is it?
T squared.
T squared. So if you just took 98 divided by 4.905, that would tell you what t squared is, but it will not tell you what t is. So I showed you this a few days ago when I gave you that really difficult problem and you had to get rid of the r squared a couple days ago. Do you remember what we had to do? Square root. Square root will get rid of or undo something squared. And if you do it to one side, you do it to the other. So you're going to take 98 divided by 4.905 and then take the square root of that to get your answer. I want everyone to do it because I want to make sure that you know how to get the square root on your particular calculator because it's likely to show up on a test. Yep. So you would probably push. That's your solve here. The square root is there. Blue. See it? Second. Square root is plug in that. Still working? Still working? Okay, well, this is why I don't want you guys to bring. If you have a calculator like that, alright, so the square root down here is right there, it's the green one. Do the second there.
Oh, yeah.
9, 7, second, square root. Oh, shoot.
Mari.
What? There you go. I want to learn. That's the first time I've ever said.
She will tie you up in a corner.
No.
Hey, Kramer.
Mari.
Kramer, don't listen to Mari. She's full of beans.
Why?
Can I get in my worksheet?
Yes, I do.
Yeah, hand out the worksheets for everybody.
Yay.
No, Mari.
Oh my goodness. This really isn't very very hard though, so it's like a paper.
She said you.
Oh, I was like, what?
Everything can't assign homework after the bell.
I assigned it before the bell, I just didn't give it to you.
Oh, ow,
It was everyone else in the class.
Yeah, everyone else did it too. I honestly don't think
We didn't have
it's not like music very
I'm
much.
literally running to the lunchroom right now.
What did you do to get that?
Okay.
Right.
Wait, never mind.
This is a lot of work. Hey, you have ready for it? I'm not doing yours.
You're a great friend.
I mean, it's a good one.
I think you're working hard. I texted you after school.